Okay, hi everyone, welcome to C1. This is the first video for chemistry on atoms and elements. So it's completely up to you how you want to do this. You can just sit and watch and listen, or you can make some notes as I'm going through it. I'm going to go through some examples, I'm going to go through some definitions, but just follow along. Remember, you can pause it, you can fast forward, you can rewind if you need to. It's completely up to you. Okay, so let's just get started. Right, so an atom, definition of an atom is the smallest part of a substance. So they always like to ask you for definitions, just as a one marker in the exam. So it's really important you do know these definitions. If I was you, I'd maybe create some sort of glossary, just on a separate piece of paper or in the back of your book, just so you've got all those keywords and their definitions in there for you to learn. So an atom is the smallest part of a substance. The size of an atom, its radius, is about 1 × 10 to the minus 10 meters. So I have seen exam style questions ask you for the dimensions, so maybe just take a note of that. 1 × 10 to the minus 10 meters. So atoms are tiny, that's why you've got that minus 10 there. Effectively, this is 0.00009 zeros, 1, 2, 3, 4, 5, 6, 7, 8, 9 meters. That's the radius of an atom. But we're just writing it shorthand like this, as opposed to writing all those zeros out all the time. Okay, so the structure of an atom then. The atom contains 3 subatomic particles. So the 3 subatomic particles are protons, neutrons, and electrons. And all that means is what is inside the atom, what is the atom actually made out of? And it's these 3 particles here. So if we have a look at an atom has a nucleus, and it's also got shells around the outside, which look a bit like this. And the subatomic particles fit into this atom. So in the centre, in the nucleus, we have protons and we have neutrons. So 2 subatomic particles in the centre, in the nucleus. In these shells or orbitals, we find electrons. So in the orbitals or shells, we find electrons. And it's really important you know where you find these in the atom. So let's talk about the charge. The charge meaning, is it positive, is it negative, or is it neutral? So with protons, protons have a +1 charge. Electrons, on the other hand, have a -1 charge, and it's always the case. Neutrons are neutral, they have a 0 charge. Okay? So it's up to you. If you want to copy this down, that's absolutely fine. Pause the video and you can take notes. I'm just going to wipe the board now because I'm running out of space. Okay, so you'll often see it as a table like this that you have to fill in. So it'll say subatomic particle here. It'll say charge, relative mass, and where is it found. So, might make that a bit bigger. Okay, so the first subatomic particle, why don't we look at protons? So charge of a proton, like I said, is +1. Electron is -1. And the neutron is 0. Okay, so relative mass. What that means is, relative meaning in comparison. how big or how small are protons, electrons and neutrons in comparison with each other? So remember, atoms are tiny, they're the smallest part of a substance. We can't put them on a balance or a weighing scale and say it's 50 kilograms or 10 kilograms because they're so tiny. All we can do is compare them in terms of size. So the relative mass of a proton is 1. The relative mass of a neutron is 1. So what this means is protons and neutrons are the same size. That's all it means. Protons are 1, neutrons are 1, therefore they're the same. However, electrons are tiny in comparison. Electrons have a relative mass of 0.0005. So in comparison to 1, it's tiny. So all that tells you electrons are a lot smaller than protons and neutrons. So where are they found? We went through this. So protons are found in the nucleus. Neutrons are also found in the nucleus. And electrons are found in orbitals, or you can write shells. That's fine. Same thing. Okay. Right then. Let's carry on. Let's have a look at the periodic table, where we can work out how many subatomic particles there are from the periodic table. So I'm just going to pick any element at random. I'm going to pick sodium, Na. So sodium has 2 numbers. If you have a look at the periodic table, you'll have a top number and you'll have a bottom number. And it's really important you know what each number stands for. So the top one is your mass number. And the mass number tells us how many protons there are plus neutrons. So they're added together. Protons and neutrons are added together to create this value here, 23. The bottom number is the atomic number, which is the number of protons. But it's also equal to the number of electrons. Because remember, protons have a positive charge. So let's say, okay, I've got 11 protons here for sodium. So my atom has an 11 plus charge. It also has 11 electrons, so it has an 11 negative charge. So these 2 charges cancel out, and that's why this element overall has no charge. It's neutral, because the positive charge and the negative charge cancel out. So protons and electrons are always the same for elements. Okay. So I'll just write it out here on the side then. So protons equals 11, it's the bottom number. Electrons equals 11. Again, it's the same, it's the bottom number. Neutrons, however, what we do is we do top number minus bottom, mass number minus atomic number. So 23 minus 11 equals 12. So that's my number of neutrons, 12. Because if I know I've got 11 protons and protons plus neutrons equals 23, effectively it's 23 minus 11, so 23 is protons plus neutrons, minus 11, which is the protons, will give me just the neutrons, which is 12 in this case. Okay then, right, let's go on to a couple more definitions then. So elements, the definition of an element. An element, so you find elements on the periodic table, that's why it's called the periodic table of elements. So elements are pure, they only contain one type of atom. So for instance, let's say magnesium. Magnesium is only made up of magnesium atoms. There's nothing else in there. There's no silver, there's no gold, there's no carbon, nothing but magnesium atoms. And it's the same for every other element on the periodic table. They only contain one type of atom. However, a compound, on the other hand, compounds contain 2 or more different elements, 2 or more different elements chemically bonded together. So for instance, let's have a look at H2O. You've got hydrogen, 2 hydrogens, and you've got 1 oxygen chemically bonded together. They're 2 different elements, therefore they're a compound. Or with CO2, you've got carbon and you've got oxygen. They're 2 different elements chemically bonded together. Or we could do NaSO4. You've got sodium, you've got sulfur, and you've got oxygen. That's 3 different elements chemically bonded together. And that's key. 2 or more different. Make sure you have that word written down. Different elements chemically bonded together. Okay, and then the last one is a mixture. So a mixture can be separated. It's where elements and compounds are not chemically bonded together. Oh, coming out of space. Are not chemically bonded together. I'll just squeeze it up here. Can be separated. That's your key point here. Can be separated. Mixtures can be separated. So think of it as like a bag of M&Ms. You get all those different colours in the bag of M&Ms, don't you? You can actually pick out those different colours and separate them out into the different M&Ms, the red ones, the blue ones, the green ones, and that's just like a mixture. It contains all these elements and compounds, but they're not chemically bonded together, so you can actually separate them out. Okay, last bit then, isotopes. That's the last bit that we're going to look at in this video, isotopes. So what is an isotope? An isotope, they're just different versions of an element. So think of it as a bag of Walker's crisps, right? You get ready salted, you get salt and vinegar, and you get cheese and onion. They're still Walker's. They're still the same crisp. They're still made from potatoes. They're exactly the same. The only difference is the flavour. And that's what isotopes are. Isotopes are different forms of the same element. Different forms of the same element. So for example, you can get carbon-12, carbon-13, and carbon-14. They're still carbon, they're all still carbon. The only difference is the number of neutrons. So isotopes have, same number of protons and electrons, but different number of neutrons, and that's key here. Neutrons are different. So let me prove that to you then. So carbon 12 has 6 as its atomic number. So does carbon 13, and so does carbon 14. Let's do what we did before then. So let's work out how many protons, neutrons, and electrons there are for each of these. So let's have a look at carbon 12 first then. So carbon 12, remember the bottom number tells you how many electrons there are and how many protons there are. So they're both 6. So what do we do to work out neutrons? It's bottom minus top. So 12 minus 6 is 6. Carbon 13. So protons is 6, it's the atomic number. Electrons is 6, it's the atomic number. Neutrons is mass number minus atomic, so 7. Carbon 14. Bottom number tells us protons, also tells us electrons. Top minus bottom gives us neutrons. So, can you see then? Look at the difference in neutrons for the 3 isotopes of carbon. Carbon 12 has 6 neutrons, carbon 13 has 7 neutrons, and carbon 14 has 8 neutrons. And that's it, that's an isotope. Same number of protons and electrons, different number of neutrons. Okay then, thank you for watching. Remember, you can rewind it, you can pause it. If you weren't sure, then go back, have another go.